Good day, ladies and gents. Welcome to BK Mathematics. And we are given a problem on the board to solve. It reads: if y is equal 5 upon 1 minus x squared is equal 3, then show that 1 minus x squared divided upon the x is equal 6xy. Now, in this case, we are asked to prove that this particular equation that we are given is equal to 1 minus x squared divided upon the x is equal 6xy. Okay, this is implicit function. Now, to start with, we say solution. Since we are given y is equal 5 into 1 minus x squared raised to power 3, then the first step that to do here is, because multiply, this is multiplying this and this is also multiplying this. Then we say y into 1 minus x squared raised to the power 3 is equals 5. Then the second step that I have to take here is, since this is product rule, then we say we are going to differentiate using product rule of differentiation. Now, to start with, if we are holding y constantly, we say y is constant, then differentiating y minus x squared raised to power 3, we know this is implicit function, like I said, and we are going to use chain rule to differentiate this one. Then we say differentiating this one, just like we are going to use the short method, like I said. Now, if you want to use the short method to differentiate this using chain rule, we say, since this is power 3, we say that this 3 becomes, let's try to put it in front of this bracket, becomes 3 into. Now, if you are differentiating this whole bracket, you know, if you are differentiating a constant, it is 0. Then let's try to differentiate this one. Then if you are differentiating this minus x squared, giving you minus 2x. Then after we write the whole bracket, that is 1 minus x squared. And since this is power 3 and we want to differentiate it, we just need to subtract 1 from this 3. This becomes 2. Then, after which, the next step, let's try to hold 1 minus x squared raised to power 3 constant. We say plus, we hold 1 minus x squared raised to power 3 constantly. Then we differentiate y. And since this is implicit function, differentiating y always we add dy upon dx. We know in real form, differentiating a variable, it is 1. But like we don't want to write 1, like we want to say 1 dy upon dx. That is why we are writing it straightforward, saying dy upon dx. Then the second step, let's try to multiply and see. Okay, it's equals. This is constant, and we know differentiating a constant becomes 0. Our target now is we want to show that this particular expression is equal to this. Then after which we multiply, we say y times 3 giving you 3y, and 3y times minus x giving you minus 6xy into 1 minus x squared raised to power 2 plus, we write this one, we say 1 minus x squared raised to the power 3 dy upon dx. Then everything becomes 0. Let's try to transpose this expression to this other part. Then if you do, this becomes 1 minus x raised to power 2 raised to power 3 dy upon dx is equals. When this one is moving to this other point, we are going to have 6xy into 1 minus x squared raised to the power 2. Now, we still continue from this point. Since we are having 1 minus x squared raised to the power 3 dy upon dx, everything becomes 6xy into 1 minus x squared raised to the power 2. Then, from this point, we just need to divide both sides by 1 minus x squared raised to the power 2. We divide both sides by 1 minus x squared raised to the power 2. This one cancels this. Then, if this one cancels this, what remains? We have 1 minus x squared divided by 1 minus x squared raised to the power. This is raised to the power 3, and this is raised to the power 2 dy upon dx. Everything becomes 6xy. Just like, now since you want to explain this one, let's just recall We call that whenever you're having a raised to the power 3 divided by a raised to the power 2. Now, from this point, we apply division law of indices. Then this one becomes a raised to the power 3 minus 2. From division law of indices, we say whenever you have the same sign or the same base, we take one base of them, then we subtract the power. Then this one becomes a raised to the power 1. And if the number in the letter raised to the power 1, just like the number on the letter itself, this one becomes it. Then, this what we are going to implement from this point. We are having 1 minus x raised to the power 2 raised to the power 3 divided by 1 minus x raised to the power 2 raised to the power 2. Then, the same thing at the same base, we just need to take one base of them. We say 1 minus x squared. Then we say 3 minus 2. Automatically, this one becomes 1 minus x squared raised to the power 1. Like what we did here, if this is raised to the power 1, just like 1 minus x squared. Okay, now from this point, we already expressing this 1 minus x squared cubed divided by 1 minus x squared raised to the power 2 as 1 minus x squared. Then our answer then becomes, from this point, our answer then becomes, we say 1 minus x squared dy upon dx automatically becomes 6xy as required. It's what we are asked to show. Now you can see from this, it is equal to this. Automatically we have proved that y is equal 5 upon 1 minus x squared raised to the power cube is equal to 1 minus x squared dy upon dx is equal 6xy as our final answer. Okay? Thank you for watching. Make sure you share for others to benefit. Okay?
Oh, you good.